My name is Jacob Ideskog from Stockholm, Sweden, and I work at Curity, an identity company, as identity specialist, I guess, and product manager. So I'll be talking some today about things we see all the time when we meet customers. We see that security is usually in the way, and we feel that's a misconception. Security should be an enabler. And I'm going to try to dive into that a bit by looking some things on what problems do we have, what are we facing, what does our systems look like, really high level, what conflict is there really, and how do we approach that? How can we isolate the various components of our systems to sort of bridge this gap of understanding between our different groups in our organizations? And how can we keep this knowledge for the future? Because that's really one of the biggest issues. So, security is a huge topic. And as an identity company, we kind of zoom in on this a bit. So I'm not going to talk about all these areas because we have security on how you enter your building, we have security on how you access your machines, security on the network, which computer can talk to which, the virtual networks. We have behavioral security, what's going on the network, even though you're talking to the right one or you're doing the right thing. We have application level security, we have data access security. There's all kinds of security if you start go into that rabbit hole. So what we're going to focus on is the thing that binds these things together. Identity. Because if you don't know who is trying to do something, it's pretty hard to determine if it's okay. So identity is the glue that kind of brings all of these security questions together. And instead of focusing on that entire stack of problems from machine up to application, I'm going to talk about the things that are more relevant to the people in this room. We're going to stop at the service layer. So let's just assume we have back-end applications, microservices, if you will, or event buses, or whatever we use in our backends. And we have applications. So when we're starting to think about how do we figure out who someone is in these systems, we pretty quickly realize that we have a problem. Very, very often, each of these applications on the front end are responsible for authenticating a user, figuring out who is this user, and they do it differently. So you have application A getting a blue user, and application B getting the same user but pink. Different parts of the user is visible. And then they transmit this information down into the APIs, and the APIs transmit this around, and the image is shattered even more. You get smaller and smaller pieces of the user, and not every part of the system is capable or even has the possibility to see the same user. So information is lost, and we struggle to sort of unify this. And why is this? Well, I have two candidates to blame. I blame agility and I blame time to market. And we want both. So we want to be able to continuously deliver, and we want to be able to get our products out quickly. And what we want to do is we want to build more mobile applications, more single-page applications, more web applications, more backends, more event-driven systems. Everything just faster, better, and more. So the conflict that we're seeing is that we have two sides of this in our organization. We want to be agile. We have product requirements on us that say, it should do this, it should look like this, it should be super useful. And then we have the security team saying, yeah, it should be useful, but it needs to be secure. And those typically go head-on with each other if not done right. We want reusability, not only usability. We want the component to be usable in the next, like we just heard. And if we can, it'd be great if it could be forward compatible, not only backwards compatible, so that what we build today can work with what's being built tomorrow. That's a tricky problem, and that's not a problem that helps you with your time to market. So the consequence of this conflict is that our teams that are developing our mobile apps, they also have a small post-it on the board saying, build login. They go and grab that post-it, and they're like, okay, login. Yeah, we're going to use username, password. We have that LDAP server over there. I'll just do it like this. So we got solution A. And then team B comes in, builds another app. We get solution B, solution C, solution D. So we end up with all kinds of solutions for authentication. And even if we're not doing that today, a lot of organizations that we're seeing, we at least have this from before. So we have this huge legacy of various solutions that we need to deal with. And like we saw in the beginning, all of these various login solutions, they are going to give different types of data to the API. So the API stands there in the bottom and is wondering, okay, could you guys at least give me something that I can use so I don't have to go and fetch additional data all the time? And that may simply not be possible, because they may not have the information in the applications. So we go to the management and we say we need to solve this, and we can buy something maybe to solve this. And we do. Perhaps we buy a firewall, a gateway. Those are great, by the way, but there's a big but there. They usually work like this. You have some secret to enter into your sort of API world. So you have to authenticate somehow, hopefully. Could be just an API key also. And then once you've done that, you pass it on. So the gateway sometimes figures out, okay, it was this part of the request that I need to look at, add some more information, create some sort of header, sends it down to the API. The API knows, okay, that was Jacob, who's the user for this request. Pretty common way to do it, actually. Which means we end up with a split world here where we're somewhat secure, perhaps, on the outside, if we're lucky. But we got wide open doors as soon as you enter the gateway. Is that a problem? I mean, it's our organization. We trust everybody who works there. Do we? Yeah, perhaps. But we still can make mistakes. It's still pretty easy to actually fire something in the wrong direction and accidentally access an API that wasn't intended to be accessed. I've been at organizations who didn't believe their assets were high value, but if something would go wrong with their assets, the person in charge would be fired and probably prosecuted, because it was high value. They just didn't realize it. And their backends were completely open like this, which meant any person on their network who was working developing their APIs could actually make a request with the correct headers and do something with their APIs that they weren't intended for, or that he wasn't or she wasn't authorized for. So even though we are on our network, we are not safe and secure. We need to protect ourselves from both mistakes and also malicious attacks. Okay, so that was the backend. That's how we try to at least unify the information that comes to the backend. What about the front ends? How do we do it with the logins then? Well, we try to convey knowledge. We have meetings. We talk to each other. We say, we wrote this in the first application. You should try to reuse all of that in the next. And the person who is going to write the next application said, oh, yeah, right. We wrote most of it already. So, yeah, we'll take some of that. And then you set up meetings together in your organization. You start documenting the patterns that we're supposed to use. And yeah, the problem with this is usually this happens in the end of a project. You've done the entire project. Your solution is out there. 2 guys are left. And they're supposed to document now what happened. And yeah, that's not the most fun part of the work necessarily, so the documentation can vary. Sometimes it's really good, sometimes it's less good. And then it's up to the next team to actually read whatever was written. So this is a poor form of maintaining knowledge in the organization, even though it's necessary, I agree. So what we do need instead is, we need patterns. I think the way we understand systems is based on what we've seen before, on our ability to map it to something we've seen before. And security is one of those things that looks tricky on the outside, but if you can look at it a bit more deeper, you can see that it's actually the same thing as we're doing in other areas. We just need to open up the box a bit. And if we do, then we actually start understanding, okay, this is what we're supposed to be doing. So how do we do this then? Well, we're going to need to use reusable components for once. That's what we do everywhere else. And in fact, that's how even we started building programs in the first place. When Unix was designed in the beginning, Doug McElroy had this great idea that we should write programs that do one thing and do it really well. And we should write programs that work together. That was the beginning. And we used to have this. We used to have some mobile application with a backend, with a database, performing some function for our company. And then we built another one, another application, just like James explained, with a backend, and it worked for its purpose. And then we had the third. But now we don't do this. Now we're building general purpose backends. We're building microservices that do one thing and do it really well, and we don't really care who is using it because it's not built for the user, for a particular user. It's built for any user. And then we build front ends. It could be an app, it could be a single page application. It doesn't really matter because we're separating the concern. We made reusable components. We don't put a data store per each, well, if we're lucky. We try to unify our infrastructure. So separation of concern. This is how we're building stuff. So security-wise, what's missing then? Well, let's look at the requirements. We saw the back end already. We put a gateway there, and we think we can figure out a way to unify at least what identity information is going in there, even though it wasn't secure. But what about the front ends? What about how we actually figured out who this user was? Well, we have a mobile application. It has a few requirements. It needs to know some sort of login status. Is the user logged in or not? Was the user logged in strongly? Multi-factor? Yeah. How much do we know? We need some user information. We probably don't need a lot in the front end. Depends. But usually they're lightweight, so we probably only need some. And we need API access. We need to call the APIs for this user, on this user's behalf. And a single page application, same thing. We need some login status. We need some user information. Probably not the same user information for every application. That's good to point out. And we need API access. Maybe not the same API access. Maybe we're going to call different APIs. And we look at the API. Here we need other things, actually. Here we need entitlement information. We need to know, OK, you're making this call. Are you authorized to do so? Is this OK? And we need probably a lot more user information in the backend, because here's where the things actually happen. Here's where we actually do transactions on the user's behalf. So maybe we need to know stuff now. In the front end, we could just say, hello, Jacob. In the back end, we're actually going to transfer money. Why don't we need login status in the back end? Well, we could argue that you should have that. But you could also argue that if you log in strongly, you're entitled to more. So if we add entitlement information and give that to the backend, that's probably more relevant. It doesn't need to know, did you log in with Google, or did you log in with some sort of bank identifier? So with all this, we're introducing the identity management systems. It's a system that can handle these requirements. So let's start. Let's say I am an application. I'm going to ask the IMS, log in this user, please. And the IMS does something and says, sure, here's the ticket proving I did. We usually call it tokens, but ticket works as well. This is what's called a token-based architecture I'm going to talk about now. Big new monolith? Not really. So if you think of Bash in Unix, that looks like a monolithic system. But once you start looking at what Bash really is, it's just a bunch of really small programs that do one thing and do it really well. You have sed, you have grep, you have cd, you have, all of those. They're not actually one giant program. There are tons. So is the IMS. It's not just one big thing. It's split into architectural components. We call it the neo-security architecture, because it's good to have a name. It has at least these components. Usually, we have more. But to do the basics, you need something that can authenticate. Authentication is the process of figuring out who a user is. Authentication can be done using Facebook, Google, username, password, SMS, email, key fob, application on the phone, anything. You walked into a room, perhaps you're authenticated because you're just there. Who knows? Lots of stuff. So the authentication service is responsible for figuring out who are you, using any means necessary. A token service does something else. It does not figure out who you are. It has no idea how to do that. Instead, it relies on, if somebody tells it, here's a user, it has logged in, it has these properties, it can issue tokens. It can issue cryptographic or other types of tickets that it can send out that proves that this user is who it says it is, and something has happened, it has logged in, or it has granted access, or something like that. Then we have a federation service. Federation is, okay, we need to authenticate, but we can't authenticate here. We need to go and ask our partner organization, because that user is an employee there. Let's federate over there. That's the name for it. The user logs in using Kerberos, perhaps on its local laptop at that organization, jumps back, and now we can continue issuing tokens. So sometimes you need that, not always. And then a user management service. Another problem. We need to not only use the users and find the accounts, we need to also update them. We need to be able to create a new user, provision stuff on a user, provision users between systems. That's what a user management service is. And then, of course, we need user repositories. We need places to put stuff. OK. So we got the IMS. What's the continuum then? So Doug and McElroy, when they defined the Unix idioms, said, well, we should not only write programs that do one thing, we should write programs to handle text streams, because that's the universal interface. Back in the day, at least. So text streams are not what we're going to use, but standards, they are the text streams of security. They are the uniform interface between components in a security world. Here's a few. We call it the neo-security stack. It's a bunch of standards that are useful when you're building these type of applications. As you can see, you don't only need one. You need a bunch, because they do different things. We have OAuth for API access. We have OpenID for the identity layer on top of OAuth. We have Jose. I don't know if you've heard of that, but JavaScript object signing and encryption, more known as JOTs, JSON Web Tokens. They're defined in the Jose spec. We have SCIM for user provisioning, and we have SAML. SAML is an odd bird in here, because it's not a new standard, and it doesn't do mobile really well. So why did I put that there? Well, you probably are going to talk to some legacy system somewhere, and if you do, they're most likely going to talk SAML. So until they move to OpenID, we're going to have to keep that on that slide, unfortunately. But it's a good standard still. So let's map it in. We have our IMS. So the Federation Service, you guessed it, that's SAML. The User Management Service. Here we talk SCIM. SCIM is a great protocol. It's very, very simple. It's a RESTful protocol with a JSON schema. And the JSON schema defines what a user account looks like. So think of LDAP, but for 2019. So you can do a user CRUD, patch, update, delete, anything you want on an account. You can list accounts. So it's super, super useful. So if your API gets some sort of user information and it needs more, there's a standard way to get that. Just call the User Management Service. Make it OAuth protected, by the way, so it's standardized how you call it. Token service. There's two standards in here. First of all, OAuth. OAuth is the token protocol. It's the protocol to issue tokens for data access, or API access, I should say. But on top of that is another protocol called OpenID. OpenID adds more tokens. It sends tokens to the client as well, so the client can know who authenticated. Actually, OpenID could be placed in the Federation Service box, but I like to put it in the token service box. It's tied to OAuth quite a lot. The authentication service then, the last one. Well, here we run into something more interesting. There is no one authentication standard. It's actually a problem that is not possible to solve like that. Because authentication, as I mentioned before, could be a pigeon that you send to your neighbor, and he finds a code message in there and blinks a flashlight 2 times, and you're authenticated. That's hard to standardize the same way as you would when you send a text message and click a link. So you can standardize how you sort of start authentication, which is what OpenID does, and how you finish, what the result is, the tokens you get, also OpenID, but you can't really standardize each and every step in between there. So instead, there's a bunch of standards. There's FIDO and U2F defining challenge standards. Nowadays, WebAuth. We have HOTP and TOTP for one-time passwords. And there's a lot of custom implementations and variants here that you need support. So that's why we have an authentication service to deal with this. We don't want every system. We don't want the token service to have to deal with how to send a pigeon over. We want one system to deal with that, and then transform an image to, or a canonized picture of the user over to the token service. So we sort of make it do one thing really well, and that one thing is actually multiplexing authentication. That's what an authentication service is doing. It's just calling various authentication methods. Okay, so now what? So we're back. Log this user in, please. Sure, here's the ticket proving I did. So what happened? Log this user in actually didn't just go to the IMS, it went to the token service, because that's where you go. And the token service says, great, I have no idea who this user is, and I need to figure that out. Send it over to the authentication service. The authentication service in turn says, oh, okay, this one goes to Facebook. And you're back. Go to the token service, issue a ticket. And by the way, issue another one so you can access APIs as well. A single page application, log this user in. Probably a different flow, but still, it will go to the OAuth and OpenID Connect in the token service. The token service still doesn't know how to authenticate, so it still will go to the authentication service. The authentication service will figure it out, go back, and tokens are issued. Okay, so let's look at the API then. Now we have the token, we have the API access token in the mobile application. So we want to get some data on this user's behalf. We're passing it down to the API in the request. The API simply needs to check them. Well, is this a valid token? It calls the token service. The token service says, yeah, it's John Doe. It's valid. The API can then decide if John Doe should get this data or not. That's another question, actually. But let's assume it does. So we can go on. You see how we can communicate with various parts of this IMS to achieve this identity layer on top. And with this, we can now start looking at longevity. We're building all of these APIs, but now all they ever will get is a token that contains enough information for it to be able to determine who is calling, on whose user's behalf is the operation being made. Well, that sounds easy then. That's easy to build into a library. That will be the same thing in the pipeline every time. Just unpack the token, check that it's valid, same operation every time, create the user principal or whatever you do, fire it on. So with the gateway then, like I said, I don't dislike gateways, they're great, but this is how you should be using them. You should be sending an opaque token in, a token that you can't decode unless you know how to contact the token service. So the mobile app calls the gateway. The gateway then figures out, okay, opaque new token, never seen before, call the token service. Is this valid? The token service then says, no, it doesn't just respond with John Doe, it instead transforms that token into one of those Jose tokens, JSON Web Tokens. So it returns a JOT instead and says, here's a JOT. Gateway caches this, fires the JOT onto the API. A JOT contains all data that you need. You just unpack it, and it's all there. So you don't need to make extra calls after this. So what happened now? Well, we're secure on the front, and we're still secure in the back end. Now it's pretty hard, actually, to make a mistake and send a request to a system that you're not intended or allowed to do so for. You can't just go and put stuff in the header. You actually need to call a token service to get a token, because it's signed now by that private key that fewer people know in your organization. Because private keys, you usually understand those are private, so people tend to sort of keep those safe. So we can now be sure that our backends actually will do what they're intended to do, always. So what about mobile applications? Well, it turns out if we use OpenID to log in, there's libraries for that too. And the standard grows, but it's maintained in a way where what you built before can be used tomorrow. So we're getting longevity also in how we implement our mobile logins. There's a great library, actually, you should write it down, AppAuth, built by Google. It is now maintained by the OpenID Foundation. It's a really good one for mobile integrations. So now instead of sharing our knowledge with big documents and time pressure like that, we just make reusable components that follow the standards, and we share those. So to conclude, we need to write our security architecture in stone. We need to understand that it's an architecture. It's just like our other parts. We split it apart. We make sure we use standards so that we get reusability everywhere. We isolate complexity. We don't spread this thing around everywhere so that every application has to deal with log in and log out and all those things. No, we put that in a separate system with a similar architecture to just what we just built, separation of concern. We find, build, write reusable libraries for our APIs, apps, sites. All of them can be reusable because we're building them on top of standards. We look at the problem from an architectural perspective. Security is an architectural issue. It's not a development issue. We need to just understand that just like we split our apps and APIs apart, we're going to do the same thing in the security world, in the identity world. And dotative. Do one thing and do it well. Thank you.